In this case, 2 units along the x-axis and 3 units along the y-axis. Now it's interesting to note that the vectors can also be stuffs like complex numbers or even set of polynomials. Now let's recall what we had talked about the addition of vectors and scalar multiplication. Recall that it shows how to get to the tip from the tail. Now note that this means exactly the same as extending the unit vector along x-axis and y-axis and simply adding them. Now it's interesting to note that this is true for any vector on the plane. It can be represented as famously known as Goldbach's conjecture, which is unproven till date. On June 7, 1742, the German mathematician Christian Goldbach wrote a letter to Leonhard Euler in which he proposed that every integer that can be written and some positive p less than 1, plot them, then take the sum p times x1 plus 1 minus p times x2 and mark the corresponding y coordinates on the function. We will note that it is always less than or equal to p times f of x1 plus 1 minus p times f of x2 of q approaching 1. The limit can be solved using L'Hopital's rule and we will have this expression. Now when we take the sum, we note that the right hand side finally turns out to be 1 minus z to the power of minus a. This is the generalized binomial theorem. 2 notation as was used by Euler to represent the sum of divisors of a number. For example, if I write int 15, that would mean 1 plus 3 plus 5 plus 15, which is 24. Now let's have a look on some of this notation's important properties. For any two primes a and b, for instance, consider the set of all natural numbers. Clearly it has infinitely many elements. Let's denote its cardinality by this stylish a. Now let's consider the cardinality of real numbers. Again, it contains infinitely many elements, but is its cardinality equal to a? In the language of a complete graph with 5 vertices. Now why is 5 important? Because this is the chromatic number of this graph. In general, if we have a graph with chromatic number r, then its crossing number is always greater than or equal to the crossing number of the complete graph with r vertices.